Our next speaker is Fishman from Tel Aviv University.
Good afternoon. Thank you very much for the opportunity. Bravo to Manna Center and NYU for making this conference happen. I want to talk to you a little bit about farmers. They obviously play an important role in our discussion, and I think they deserve some attention. And especially I want to talk about how we can help as societies help our farmers choose sustainability. So what does this mean? I mean, we already heard about the many ways in which agriculture affects our environment. Agriculture is probably the one where our relationship with our environment is the most intense and troubled. So we know that agriculture is leading, we just heard, depletion of water resources, pollution of water resources, emission of greenhouse gases, and so nitrogen pollution. And we also know that the environment also acts back on agriculture. Agriculture both influences the environment and is affected by the environment in turn. The same damages we do to the environment pays back on our farmers. So if we deplete water, then our agriculture is having a hard time finding more water for irrigation. If we emit greenhouse gases, the change in climate, farmers are the first to suffer from the effects of a changing climate, and so forth, from degradation of soils, etc. So in order to make agriculture more sustainable, our farmers have to choose to make their production, to cultivate food in more sustainable ways, right? And the question is, how do we help our farmers make these choices? And the first question I want to raise is, what role does technology have to play in this quest? So we know that the technologies that are enabling us to produce so much food in the world today are the fruits of the Green Revolution. And what the Green Revolution did, it was basically a suite of technologies that have helped us to produce more food with more inputs. More nitrogen, more energy, more water. All of these things have helped us produce more food, and that was an amazing transformation of agriculture. And today we know, though, that we have to do something else. We have to reduce the amount of resources we use. We have to reduce our environmental burden. And there are kind of three, if I oversimplify here, there are kind of three categories of thinking of what kind of change we need to make in our cultivation methods to reduce our environmental input. One way of thinking is we have to abandon this whole idea of industrial farming, modern farming, and go back to traditional farming. So that's an interesting idea. I just think that we have to think really hard about whether it's realistic, it's still relevant today, whether it's still realistic to meet the demand for food that 9 billion people are going to have soon, and even our present population. On the other hand, there is this idea of new frontiers in science, including GMs and other technologies, which are, kind of futuristic. But in between those two extremes, of course, are very contentious. I'm not going to go into that now. But of course, between these two extremes, there's another way of thinking. There's another alternative, which is technologies that already exist and are not being used. So they're not futuristic. They're not about going back to traditional farming. There are technologies that enable farmers to achieve what is sometimes called sustainable intensification, sorry, that's a typo, sustainable intensification, which means producing more with less resources, with less water, with less energy, with less nitrogen. Those technologies exist, but they are not used on a large scale still. Why? Why are farmers not choosing to use these available technologies that would enable them to maintain a high level of production with much less pollution and environmental degradation? Well, it's basically mostly the same reasons that all of us in this room are choosing to degrade our environment. In the way we consume our energy and other products, we all make those wrong choices. None of us really choose sustainability. And the reasons we know are because many of the environmental resources are collective. There's a tragedy of the commons. Many of the damages will occur in the future, so we don't value them enough. So farmers are no different from us. Farmers are no different from any other sector of the economy that produces consumption goods and in the process harms the environment. But there is something special and even more challenging about agriculture compared to other sectors of the economy. Because in agriculture, the number of producers is much, much larger than in any other sector of the economy. every farmer is a firm, right? And in any other sector of the economy, we have relatively few firms. But agriculture, the global food, is produced by hundreds of millions of farmers. And many of these farmers operate on a very small scale, produce very low income, and operate in a very challenging socio-ecological, cultural, political, social environment. So to achieve a technological transformation with these farmers, most of them are operating in what we call developing countries or low-income countries, is a very challenging task from a social economic point of view, because they work in an environment which is very hard to regulate. They don't have access to any kind of the financial tools and other kind of services that enable those technological transformations. This makes the challenge much more difficult. Just as one example, if you look at where nitrogen is used in the world, we just heard about how the damages of overuse of nitrogen fertilizers. Well, in this map from National Geographic, they tried to map where there is excessive use of nitrogen in the world, and the green colors indicate places where there's actually too much use of nitrogen needlessly. You could reduce nitrogen use without harming productivity. And you see that a lot of this is happening not in the industrialized world, but in India and China. And the farmers who use this excessive amounts of nitrogen are all small-scale farmers who operate on land as maybe in the size of a hectare. Why are they using too much nitrogen, and how can we change that? So there are kind of four, and again, I'm oversimplifying here. I hope I'm going to make all of these four groups of scholars equally angry. I'm going to try to insult them equally because I'm really oversimplifying what they're saying, but just for the sake of being provocative, I'll have a go at it. So one point of view is, again, the more environmentalist point of view is, the way to do this is to reject all these modern agricultural technologies. Then come the economists and they say the reason people don't use environmentally efficient technologies is because the markets are not operating correctly. And what we need to do is we need to remove all kinds of subsidies, all kinds of distortions, and then tax pollution. And those are the most efficient economic tools to achieve the right balance of production and environmental degradation. So basically, once the prices are set correctly, according to economists, this is what's going to set things right and going to get farmers to adapt those technologies as more efficient technologies. Politicians don't like to listen to economists when they say that they should remove all subsidies and tax, right? So what politicians like to do is to offer more subsidies. So in the environmental realm, politicians, and I'll make this more concrete in a minute, politicians will say, we know that we're subsidizing environmental destruction. We're not going to remove these subsidies. We're not going to impose a penalty on environmental destruction, but let's subsidize technologies that reduce the environmental burden. Okay, politicians prefer to subsidize than to tax. It's easier to get votes with subsidies. And then there are deniers which say that there is not, the environmental issue is not real. We don't have to worry about this question of sustainability because societies adjust. People are very good at adjusting and adapting. So as soon as the environmental degradation will reach a point where it's really going to hurt us, then we are all just going to adapt, and farmers, particularly when they start to feel that they're running out of water, when they start to feel that their climate is changing, when they start to feel that really the pain, they will by themselves adapt these technologies and will be able to achieve, a right course of development from that point on. Okay, so these are four caricaturized views of the sustainability issue in general and especially in agriculture. And as researchers, as social science researchers, policy researchers, we try to go a little bit beyond ideology. Okay, we try to think about these things not so ideologically, but really just try to learn from evidence, from research, which of these approaches work. And again, when we focus on the so-called developing countries, where the farmers are small scale, low income, and there are so many of them, it becomes very complicated because we'll see all of these policy prescriptions are very simplistic, and we need to do better. And let me try to make it more concrete. In the case of one particular country, let's take India, for example, a small country which feeds a sixth of the world population. It has really hundreds of millions of small farmers operating throughout the country. It's hard to find a vacant piece of land in India that's not cultivated. India has had a successful green revolution in the 1960s and 70s, which enabled it to achieve the amazing feat of feeding its entire population today. But this green revolution really just took part in about the western half of India. In the areas that you see orange and red on this map, those are the areas which were successful in terms of the green revolution. But it's those same areas which are now suffering the consequences. It is those areas in which water is running out because agriculture is heavily irrigated and they're really running out of water. It's a major crisis in India. It is those places where nitrogen is used excessively, fertilizer is used excessively, polluting water resources. This has been shown to make a significant contribution to infant mortality in India. It's not just, it's really about life and death. So India is facing this severe environmental crisis that's a result of its agriculture, and again, politicians, policymakers, scholars in India are debating what do we need to do to get farmers to use less water and less nitrogen while still being able to feed the whole country. So I don't know if you can see this very well. Yeah, I think so. So India is running out of water, and yet most Indian farmers behave in the same way as the gentleman on the left is doing. This is in Gujarat, in the west of India. And this gentleman is just growing his wheat by flooding his field. This is a very inefficient use of water, despite the fact that in the same area, water is becoming very, very scarce. Very few farmers are using these kind of technologies that we are very familiar with here, like drip irrigation, that can cut the water requirements by half. So how come there is so much scarcity and yet farmers are not using all these advanced technologies that can enable to save water? So remember, we had different approaches. Economists like to think about prices. One of the problems in India is that the water is not priced. Not only is the water not priced, but even the energy, the electricity that you use for pumping the water, that is supplied for free by the government. So one of the main theories about what's going on is that Indian farmers don't have to pay for the water in any way, so naturally they don't have any incentive to use it efficiently. But this is a theory, it's never really been tested empirically. So we were involved in a field experiment which tried to do that. We worked with the local government in India, and what we did was, we know that politically you can't charge for the water, it's impossible, but let's offer farmers a compensation. Every unit of water they save below their usual use, they will receive some monetary compensation for that, the value of the electricity they save. This was supposed to generate the incentives that they would lead them to use water more efficiently, right? And most people that we talked to in India thought that this is going to be very hard to implement, but will really change how much water farmers use. So we actually found that farmers were interested in joining the program, but the program had no effect. So we had some farmers which was part of the program, and then we had a control group of farmers that they were not exposed to this incentive. And there was no difference after 1 year of the program. They still kept using the same amount of water. There was no difference between those two groups of farmers. So that really tells you that maybe pricing by itself, the kind of simplistic economic prescription of how to deal with the problem, is not going to work so simply by itself. Maybe it needs more than that. Another point of view we talked about before is that maybe there's no need to do anything because scarcity by itself will drive farmers to use water more efficiently. Right? So we took, to examine this hypothesis from a research point of view, we realized that there is this natural variation between different villages in India, that because of some geological factors, some villages are running out of water faster than others, and therefore they are experiencing greater scarcity. So this is like a natural experiment to test this idea. So then we went to all these villages and surveyed farmers, and we saw, and to see whether places that have more scarcity are actually using water more efficiently or not. And the disappointing result was that they were not. What you saw in those villages that were running out of water faster, you saw things like, maybe you can see in this picture, which is just abandonment of agriculture. So in those villages, agriculture is shrinking, and farmers are leaving. They're migrating away to cities. They're not adapting to the situation they're not adapting themselves to the situation by adapting more water efficient technologies. They're just leaving agriculture. And so it doesn't seem to be the case that more scarcity is leading to this transformation towards sustainability unless you consider abandoning agriculture a sustainable transition. Then the other type of prescription we discussed before was what the politicians like is subsidies. So again, in India, politicians love subsidizing stuff. And not only, so as a way of dealing with the problems that occur because of the fact that they're subsidizing water, they said, let's also subsidize the technologies that save water, right? Like drip irrigation. So there's a massive program in India whereby every farmer that buys drip irrigation is getting 50% or more of the cost borne by the government. And in some areas, this is actually leading to a rapid diffusion of drip irrigation in some parts of India, mostly not, but in some parts it's really leading. In some parts we're seeing more than 500,000 farmers have adapted drip irrigation. So that's great, but from an analysis we did with the government, we have data on all of these 500,000 farmers, and by analyzing this data, we realized two things that were a little bit disappointing. First of all, the subsidies only help the better off farmers, the ones that are not the smallest farmers. They have 5 hectares or more. So they're still small compared to American farmers, but they're in Indian terms considered big. The smallest and poorest farmers don't really get the benefits of, they don't use the subsidies. The other problem is that it's great when people adapt drip irrigation and use water more efficiently, but it's not clear that that is actually saving water. Because if you think about it, if I'm a farmer and I have access to a certain amount of water, and you give me drip irrigation, I could use that technology to produce the same amount of food with less water, or I can use this technology to produce double amount of food with the same water, right? And if I don't have to pay for the water, then I'm probably going to follow the second option. And therefore, so just giving a water-saving technology, and then our data shows it, does not really lead to actually a reduction in the amount of water that is extracted from the ground. So it's good for agriculture, but it's not necessarily true that it's lead to a more sustainable agriculture. So just a few examples. Let's move to the world of nitrogen. We said before that we already know that in India farmers use too much nitrogen. If they use a little bit less nitrogen fertilizers, they would save money for themselves. Their yields would not be harmed. The government will save money because the government is actually spending 1% of all Indian income is going on fertilizer subsidies. So the government would save income, farmers would save income, yields will not suffer, and fewer babies are going to die because of the pollution of water sources. So why are Indian farmers using so much nitrogen when they don't have to? One thing that the Indian government is trying to do is to give farmer information. This is a program that was really led by the Indian Prime Minister, Narendra Modi, who is, by the way, also responsible for the successful diffusion of drip irrigation in Gujarat. Another one of the programs that he's leading all over India is to go to many farmers' farms, collect soil samples, take it to a lab, test it, and then give those farmers scientific report on what amount of fertilizer they actually need to use based on scientific recommendations. And so this is a huge program at huge cost, but it's not clear whether it's really doing anything. So we did this experiment in Bihar, in one of the poorest states of India, where 500 farmers got this soil health cards. We tested their soil, gave them the recommendations. 500 did not. And disappointingly, again, after 1 year, we didn't see any effect in the amount of fertilizer they use. And we do more research to show that the reason is that farmers partially do not understand the information, and especially they don't trust the information. Okay, so it's interesting how this kind of evidence can help shape policy, and now we're doing more experiments in other parts of India to try to see how the government can make its approach more effective. So this was all really disappointing and depressing news, but I don't want you to walk away with a negative message. I don't think we should give up. I think we just have to be more creative and more sophisticated when we as society is trying to find ways to help farmers be more sustainable, whether it's here in Israel or in the US or in India and China and other developing countries. We should take this challenge seriously. It's not easy. The reality of these farmers is very complicated. We need to better understand it in order to be able to offer them the help that they need to make this transition. And I want to end up with that one positive story from Israel about a very successful transformation of fruit production in the Galilee. So what you see here is a trap that traps Mediterranean flies that eat fruits, they don't eat fruits, they nest in fruit and they damage fruit. It's a big problem here. And there's a very interesting initiative by MOP Tzafon, the R&D center in the north of Israel, which is using collective information sharing and integrated pest management, IPM, to dramatically reduce the amount of spraying in the orchards of the Galilee. So if you look at this graph, we divide, this is basically the number of sprays, the number of aerial spraying that fields are getting during the season of fruit cultivation. That's on the y-axis, and this is just over time. And the green line, and so this program started in 2012. It basically offers farmers advice and information on how when they need to spray so they don't spray unnecessarily, and also encourage them to shift to using more like traps and other IPM-based methods. And what you see, and we divided the groups into the green line indicates how many sprays are used by farmers who are cooperating with the program, listening to the advice, and the gray line is those that are not listening to the advice. So you see that until 2011, they were pretty similar, those two groups. There was a big rise in the amount of spraying used, but that is associated with the phasing out of the most toxic chemicals. In response to that, farmers seem to be spraying more to be able to deal with the fly. But look what happens after the program starts. You see the green and the gray lines separating. The gray lines are farmers who keep doing the same thing. They do not cooperate with the program. But the green line represents a dramatic reduction in spraying that farmers who are cooperating with the program are actually achieving, and this is a very large-scale success of an IPM program. And infection does not go up, the damages don't go up, so it's very successful. And I think it's a good illustration of how many successes there are in Israel that deal with environmental stress. Israel has so much knowledge that helps it deal with a difficult climate, helps its agriculture flourish with no water, reduce spraying, reduce pesticide use. So Israel has a lot to offer, especially the developing world. And I just want to end by telling you about a workshop, another workshop Manna Center is running on July 13th, where we're going to have a lot of people who are working to bring Israeli sustainable practice in agriculture to the developing world. You're all welcome to join us. Thank you.